So the first lab we'll do is we're going to let y'all measure wires and then determine their gauge number. And we'll have you do it. I think you record them in both inches and millimeters, I think, is the way the lab's set up. I need to run it off. We're going to use a type of mic called an outside mic, micrometer, but most people just call them mics. Of course, what do we use mics for? Making precise measurements, right? So the one we got here is an outside mic, which means it's designed to measure the thickness of something. Then we have what we call depth gauges, which gives you the ability to measure depth of something. This would be pretty important, like if you was going to get a screw or that had screws come in certain lengths, right? And you don't want them to bottom out. If you're like me, you'll stick them in there, they don't fit, you cut them off a little bit. We really could measure that before we even get started, right? Outside, inside mics, we have outside mics, we have inside mics, and then we have depth gauges. And then so these are different types of mics. The one we're going to use is this outside mic like this, very familiar with this, or very similar to this one. This would be a depth gauge, and then of course we have inside and outside. We don't have an inside micrometer here. That's not true. This is not called a micrometer. This is called a caliper, but it's basically the same thing. Instead of being a rotary mic like that one is, this is actually a linear. Dang, I went right back. Slow down a bit. Slow down a bit. So this is a combination of several mics. So this would be an outside mic. Well, if we go and look on this side over here, notice these things spread apart. So this would be an inside mic. Okay. And then this also has a depth gauge on the side, on the bottom. So notice when I move it down, the thing on the bottom extends. And what you do is you combine two things. We'll look. We have this scale right here. It'll focus in. So we'd look at this flat side right here, and then we have a dial that would give us the fractional portion that we're looking at. Does that make sense? And we'll look at that too. The one we got is this mic right here, and this is kind of different in that it can measure anywhere from 0 to 4 inches. And what we do is we change out this guy right here that we call the amble. So if you look inside the kit, we have several different ambles you could put in there depending on what size or range you wanted to measure. Does that make sense? And so this is the amble right here. So here's the parts right here. So we have the amble. Everybody see, I'm sorry. These are the measuring rods. So what we do is whatever we want to measure, we put between the amble and the spindle, and we move the spindle up until it barely makes contact with what we want to measure. And then we read the dials. That makes sense? We're okay. Also, we have some type of latching mechanism on there that we have the ability to latch it, because you make a measurement, and these things are so precise, just pulling it out and trying to carry it and show it somewhere, you could cause it to do what? To move. So we have a latch on this. Ours is a little different than the one that I got on the PowerPoint. So here's our latch right here. So right below this right here, you turn this and this will latch it. If you turn it one direction, then it'll be latched. You see what I'm talking about? Right here. This thumb wheel right here. So right now mine is unlatched, so I can spin it real easy. But I take it and turn it clockwise, and then it latches down. Okay? So that way we can move it around while we're reading it. So normally what we do is we'd make a reading, we'd latch it down, we'd pick it up now, and we can move it around. Are we okay so far? By the way, if you look in there, it's got three standards in there that we would do to check to see if our this is the one with the black plastic ring around the side. Those are our standards, which we could check to see how accurate the mic was. But you gotta set 0 on it first. So we'll show you how to do that in a minute. So we got to 0 these things. Most of our indicators that has the ability to make measurements, we have the ability to 0 it. So if you run it up until they barely touch, and we'll show you how to do that. So we got two things to set the thing. We got what we call the thimble, and we got what we call the ratchet cap. When you start getting so you can use the thimble to move it real fast, but eventually you're going to move back to the little ratchet cap. And what we do is we'll turn that little ratchet clamp until it touches and clicks one time, and then we make our measurement. So it's just that means we're just going to be touching the surface, and we're not going to push into the surface, right? So what are y'all going to do? So y'all can like play around with it. So what I'll do is right now, so if my spindle is down here somewhere, then what I can do is I would spin my spindle until I got close, and then I would move back to the ratchet cap, and then I would start moving that. And you notice when it hits, you turn it a little bit, it'll click. And as soon as it clicks that one time, you're through. You don't want to sit there and make it click a bunch of times. As soon as it clicks that first time, and then I would turn around and make my measurement. Of course, y'all can see we're going to make our measurements down here. Are we okay so far? So this is the outside mic scale. So what we have is it's called a barrel scale. And the large divisions is worth 0.1 inches or 100 millinches. And each small division is worth what? 0.025 quarters. And then we have thousandths out there on the actual spindle itself. Are we okay? Let's show you how to do this. So first we turn the thimble until the space between the anvil and the spindle, the two rods, is wider than the device to be measured. Second, we place the device to be measured between the anvil and the spindle. Y'all understand those terms? Here we go back to the picture. Oops, wrong way, Rich. So here we go. So let's get the terms down. So everybody knows that the anvil is the stick, the spindle is the one that moves. The thing we spin around we call the what? Thimble. And this guy we call the ratchet cap. And then this is the barrel, so they call it the barrel scale or hub. So now we can use terms, right? Yeah. First turn the thimble, right? Then you do what? Then you start turning the ratchet cap until it clicks how many times? One time. Fourth, then you do what? Lock wheel, which the picture I had don't have that, but I showed you where the lock wheel is, right? Everybody okay there? Fifth, we remove the device to be moved, and then the sixth, we read the measurement. So this is the steps 1, 2, 3, 4, 5, 6 for doing this. Everybody okay? Any questions? Reading. First, we need to determine how many major divisions are shown on the barrel. So I would look at this and I would say, how many major divisions? I'd say 5. Right? Y'all understand? Yes or no? Then I would do what? Yeah, then on this micron, so this would be 0.5. So we're going to move on. Okay. Then next, we need to check how many minor divisions are shown after the last whole number in the barrel. In this case, there's 3 after the 5, right? And of course, every 3 is worth 0.25. So if we multiply 0.25 times 3, that gives me 0.75. 0.075. I'm sorry, I can do math. Are we okay? Yes or no? Okay. Then what we're going to do is we're going to stick the 5 on the other side. So far we got what? Well, so far we got 0.575. That's what we got so far. Okay, y'all understand? 575 milliinches. Because we did this. So we come up here and we look at these. We look at what's the last one I see? Okay, so I would put 0.5. Then I come over and say 1, 2, 3. Now I'm not worried about that space. That's what the thimble's for. Okay. So I'm gonna say 1, 2, 3. Okay. And then I would multiply that by 3 and I would be sitting right here so far. 0.575. But we're still not close enough, right? Everybody okay? Third step is I read the thimble. Here we are looking for the mark that is most closely aligned to the center line.
It's like 12,000.
So each one of those marks is 1/1000th of an inch. So we come over here and I say, here's 10, right? Here's 10, 11, 12. If it's in the center, we just guesstimate. But it's still we're going to be within 1/1000th of an inch, right? Real close. So what I'm going to do now is I'm going to sum all these together. So I'm going to say 0.500 plus 0.75 plus 0.012, and we're through. $587 milliinches, guys. And this is going to be accurate to better than 1/1000. So even if I'm in here somewhere and I guesstimate, I'm still going to be better than 1/1000. If I choose the next lower line or the next upper line, I'm within 1/1000. If I guesstimate between the center, I'm better than 1/1000, right? Y'all understand that? Does that make sense? 0.7, 0.587. Is that what I came up with? Okay, guys, what does this measure? We don't see a major division yet. I don't see a major division. That means it's less than 1. Okay. I count 1, 2. All I see is 2. So that's going to be 0.05.
20 and 0, so you gotta come up.
Now, 0's up here, but this would be what? 22. Yeah, 0.072. Are we okay? Because these are in 25,000s. Some people say, well, why is there only 25? 1, 2, 3, 4, 5? Because these are 25,000s, right? You understand that?
Yeah.
Each one of these minor marks. So it's gonna start back over. So if I went past 0, I would get another line. .072, and this is the inches. What would this measure?
That's 5.5.
And you could understand, after a while, you use this, you would do it. I mean, it would be in your head, right?
Yeah.
Because you know this would be 0.25. This would be, 0.025, 0.05, 0.075, and then we roll over, right?
Yeah. Well, I think it's 0.5.
So I come up here, I take this number right here, 500, right? Then I go 1, 2, 3. So it's going to be point what? That's going to be 0.75 if I'm doing all the math. And then this would be what? There's 15 right there.
You go
Back one. Right. Is that what we got? Everybody get that? Everybody okay?
Yeah.
So y'all are experts now. So what would the rating be here? So y'all can read my comment. Can't see that line right there.
Oh, yeah.
Can't see it. There, can't see a line right there. You'd see that line right there. We can't see that line right there. But you can see.
That's my vote.
So
7, 42, 40.
that's what we. That don't mean. That's not.
Oh,
mean.
wait, no, there's a 5, so that should be, 747.
Yeah. Don't do that. 27.7. But what I'm saying, you know, after you did this for, if you used a micrometer for a living, this would be in your head, because you would count these in fives. You know that would be what? That'd be 0.025, right? This would be 0.05. This would be 0.075, and you would see them, and you'd do the math in your head. So it would be
Quarter thou every day.
yes. What's this one?
36, 35.
What's 35?
Yeah. I've got 5.
See there? So y'all did that where? You did that in your what? In your head. So that's pretty neat. So looks like y'all have that down. So first thing we do is we'll check zero. How do we check zero? So what I'll do is I'll come up here and take my mic, and I'll come up here and I'll just start turning to the clicks. And then we find the line. So this is off a hair, but it's not enough to worry about.
Yeah, it's a hair.
Huh? And then just to check it again, we can take it. There's a 1-inch standard in your box somewhere. Yeah, so this is the 1-inch standard, right?
Correct.
Okay. And then what can we do? Well, we'll come in here, we'll check this. So I'm taking my thimble, turning it back down till I go past my width I want. And then I'll fit it in there. What I'm going to do, take my thimble with my ratchet cap, turn it till it clicks, and then I'm going to measure. And it lines up on 0, 0. So this, mine is really, really good. Now yeah, 0, 0. So that 0 out there is actually a 10, right? You understand that? 0, 0. So this mic right here looks like it's in pretty good shape. So what we're going to do, guys, is we're going to take some wire gauges. So we got bags, and I'll run this off. And each bag's supposed to have a number on it. I don't see one on this one, because it's basically the same wires, but they're jumbled up for depending on which bag. You know, the wires are numbered. So the wires are numbered. So when you get a stranded wire, you need to make sure it's in a nice spiral, right? You understand that? So this is stranded, and it's a twisted strand. And then what are we going to do? So we're going to take our mic, we're going to swing it up. Now we're way out here because of 1 inch. We're going to get our wire in there. We're going to turn it until it what? Clicks once. We're going to latch it down, right? Now we can pull this out, and then we can come up and do what? Then we can make our measurement. And then we're going to get our American wire gauge. We're going to look and see what that wire gauge is. Match it as close as you can, right? You'll understand stranded wire gauges stranded wires are usually going to measure a little wider than what they actually are because of the Berghagen effect. Stranded wires should be really, really close to what they're at. Of course, normal tendency now, by the way, is a lot of your machining is getting away from inches going to what? Metric or millimeter system. So you notice this outside mic, this is almost exactly like the one that's on our write-up. So this is the 1 inch outside mic. This is in centimeters. So centimeters, then each one of these small ones would be a millimeter. And then this, we would use the dial to get between the millimeters. This dial goes from 0.9, but that's going to be 0.9 centimeters, right? So you have to compensate for that. So we do this the same way. We would go in and put this up until it touches. Then we would read the main scale right here, where it lines up. And then this would be our final decimal point right there. And we would do the same thing for here, and we do the same thing for here. This over here is and we call this a caliper. I got that name, I don't know why I did. We call this the caliper, but this is for outside. This is for what? This is inside, and this is for depth. And that's what you get on the caliper. And by the way, guys, they make them digital, but that's kind of cheating, right? So if you learn how to read a dial like these, then digital would be great. Nancy's got some digital ones over there, which is pretty neat. In fact, for our machinery class, we buy plastic ones from Harbor Freight. They're like $3 a piece. Of course, because they're accurate enough, right, for teaching the class, and we're not concerned with you bending them or breaking them. So if I drop this right here, I could break my scale and stuff like that. So these are delicate pieces of equipment, guys. So try not to drop them to keep them as accurate as they possibly are. Yeah, but what's nice about this mic is that if we want, the next one gives us the ability to measure. I forgot what range it is. Now it wouldn't go all the way back down to 0. I could measure from 0, but I could measure between another range. So this guy right here will go all the way to 4 inches. Just by changing out the ample and then re-zeroing it, which is fun. So what you have to do on that one is you have to re-zero it here. And this is also for calibrating right here. I don't know if y'all can see it or not, but inside the kit, you got this little thing that looks kind of like a monkey wrench. And what you would do, you would come in here and put it into those grooves right there and turn it, and that would be one method you use to calibrate. If these are accurate enough, we're not going to fool around with those. So did I put my wire back in or no, I didn't? Which bag did I get it out of? This one. Good thing I have different colors. I think there's several different conductors inside here. We have some stranded, we have some different things. So what I'll need to do is go over there and I need to go over and run y'all guys off the lab.
You get a second. It won't close the online program. Like there's a close button, they press it on, but it won't actually close.
Oh, really? I'll have to come over and figure that out, because I don't know.
Oh,